Hey students, welcome back. We are on 2.2. This one doesn't have any homework, so that should be very exciting for us. The next few sections don't really have homework. We're just going to quickly review them, so hopefully they'll be short videos and you won't feel overwhelmed by amount of work. All right, so the very first thing that we're going to do is we're going to review that picture that we saw in yesterday's notes, or the earlier notes. So remember, it's about how close, what's like the optimum distance for a bond length. So if they're too close, there's going to be repulsion, right? So here we have repulsion, all right? Little attraction, all right? And over here, no attraction, right? And right here, this is our optimum bond length. All right, so this is like the best distance that they are apart, that our attractive forces are overcoming our repulsive forces. So that's like the perfect spot, if you will. Okay, so we're going to review Coulomb's law just kind of real quickly here. So Coulomb's law and bonding. So we have bond order. Bond order is talking about how many bonds we have. Is it a single bond, a double bond? Right, single, is it a double, is it a triple bond? All right, that's what we're talking about when we talk about bond order. So the question says, explain why the energy of a triple bond is higher than the energy of a single bond. Well, in our triple bond, we have 3 sets of electrons being shared. So that's 6 total electrons sharing or overlapping. We'll get into that a little bit later in this unit. We have 3 sets of electrons, so 6 total electrons overlapping, whereas in a single one, we only have 2 electrons or 1 set of electrons overlapping. Which one is going to be stronger, right? The 3, because there's 3 sets of overlapping, all right? More electrons, more overlap. All right, I am struggling with spelling today. That's not good. All right, let's try that again. More overlap. Okay, now let's talk about bond length. Bond length is that optimum distance that we're talking about between 2 atoms, all right, or between 2 nuclei. So how long the bond is, which is shocking. All right, so why is a triple bond shorter than a single bond? And again, that goes back to more overlap. If we have more overlap, 3 sets of electrons overlapping, right, it's going to be shorter because they're going to be pulled tighter, right? Does that make sense? So explain why a triple bond is shorter than a single bond. We have that more overlap. Getting ahead of myself, putting lap on there. More overlap. All right. Okay. That's it. See you next time.